So today's lesson, what I want to go over is panel boards, workmanship within the panel boards, and I want to give you a brief demonstration of how to open up a panel board if you're by yourself and what to watch out for and how to be careful doing that. So obviously you want to take safe precautions and have proper PPE on, and make sure that you're usually, turn the stuff off if you can. Obviously you want to keep things safe, but at the end of the day it's just a lesson, and I want to show you something about a panel board that's at our institution. So I am opening up a 250 amp panel that actually feeds another panel on the right side of this. It takes care of this panel as well. We're going to see how these wires feed through one panel into another, and we end up having an 84 circuit panel. By the time we're done, you have 84 circuits off of the one feeder. Neither one of these panels has a main circuit breaker in it, which is actually in violation of the code. I'll go over that in Article 408. It's actually okay in this case, but it'd be better to have a main circuit breaker in this. So you'll notice that I took out, we're taking off the cover off of this, and I've already taken off this screw, this one, and this one, in anticipation of me showing you the next thing. So remember that this dividing plate on the dead front, it can pivot. So if you're not careful taking this cover off, what you'll find is that if this thing twists to the left or to the right, this metal barrier could turn these breakers off. So you want to be very careful that if you're taking off a panel in an institute, that you don't want to be turning circuit breakers off in the middle of while people are working. So you want to make sure that your hand is firmly placed on this center barrier when you take this last screw off, so that this doesn't twist on you. So I've got one last screw to take off. I know that there's a lip under here that holds this panel onto the back box. So when I take this last screw off, this is not going to slide down really fast. So we're going to take this last screw off. Notice how it wants to twist. So keep in mind that this cover right here is not attached to the dead front. So as we take this last screw off, this thing wants to move. So let's take it off and I'll show you what's going on underneath it. We'll take it off. Close it. I want to show you the lip. So down at the bottom, there's that lip. This little leg right here sits on this surface, and what that does is it helps us from holding the panel and putting screws in at the same time. It makes it a little bit easier. Next thing I want to show you, we're going to take off the screwdriver and change that to 1/4 inch so I can take these screws off. This is the part that will twist. So I'm going to take the bottom two out first. Stick them in there. Take this one off. Now I'm going to be very careful that I don't turn anybody off. My hand is going to be on that bridge. Bear with me, we're almost there. Keeping a firm hand so that this dead front doesn't twist. Now notice I'm going to put my hand here, and make sure that I pull straight out. If I twisted it this way or that way, I'd be turning breakers off, and we don't want to do that. So now we're into the nitty-gritty of this panel, and really what I want to do is just kind of pick it apart and show you some things that you can expect to see. Black, red, blue represents three-phase 208. There's our grounded circuit conductor, or our neutral. Not terminated very nicely. It's got an awkward big bend. Could have been done better. Whoever tied this in obviously doesn't have much skill. The equipment ground conductor coming through looks like it got a little bit shredded. Not the end of the world. You've got a separate equipment grounding conductor bar, as you should, because the grounded circuit conductor and the equipment ground conductor shouldn't be bonded in this case. You've also got the equipment ground conductor is bonded to the back of the box as that comes through. And then notice how you've got feeders that leave. Here's another grounded circuit conductor neutral terminal. It comes down. We've got Three-phase feeds that leave is called a feed-through panel and goes in and feeds this panel. They phased with phase tape again, black, red, blue. My other video shows that these are bolt-in circuit breakers. Notice the bolts between the breakers. You can always tell if there's a big space between the breakers, that means they're bolt-in. So if you got to change this breaker out, you got to dump the panel and de-energize it so that you can change this safely. Another thing to look at is there are circuit numbers on these branch circuits. What I would have done better is I would have lined them up perfectly. They're kind of all over the place. But understand that all the odd numbers are on the left, all the even numbers are on the right. Not the worst job I've seen. You can also see that the neutrals have numbers on them. Right here, you can kind of see it up in the corner. There's little numbers on these. That's usually representative of the fact that it's a multi-wire circuit. So let's get a closer look here. You see this as 21, 17, 19, and 21. That's letting you know that that neutral is shared between 3 hot conductors. Not exactly the best way of doing things. Typically, most jobs are spec'd where you have a dedicated neutral. But if they do share them, you are required to do this by code. So at least that part of it is correct. They actually went to that extent and did that. One of the provisions of 210.4, A, B, C, and D for multi-wire circuits is that your wires be grouped. And this is grouped for a multi-wire because there's numbers on the neutral. So at least that's not a violation. And then we take a look at what we have here for raceway fill. We get into chapter 9, table 1. We'll learn about raceway fill and seeing if this is filled to more than 40% capacity. It looks like it's probably maxed, pretty close to it. So let's take another step back. Right now we got a 3-phase 208 slash 120 volt panel. A lot of the wiring could have been done a little bit neater. I don't think it's perfectly done. I would have had these nice and grouped with stick backs and my wires would have been coming in nice straight like a set of ribs. This is kind of saggy and done with, you know, average effort. So this is average electrical work in my estimation. The nipple that goes between these two panels, this is actually a rigid nipple to a chase nipple. Same thing on the other side. There's a lock nut on there to keep it snug and tight. Not the best way of doing it, but anyways, it's there. If we open up this panel, we can expect to see the same thing. So hopefully you got something out of this introduction to panel boards, and we'll see you at the next video.